All right, so thank you folks very much for your patience. As I said, if you're continuing to retake, just do so, finish up at your convenience. The only major item we have left, remember that tomorrow, by the end of tutorials at 4:20 in the afternoon, that's when all the retakes are due. If you still have a focus activity to turn in, all that needs to be taken care of by that time, because Friday morning is when I'll come in and go ahead and start applying the point bank, and then submit those grades. All right. We're going to go ahead and move on with the law of sines and the law of cosines. We're not going to be able to get very far today. In fact, we won't even be able to introduce the law of cosines. We'll be able to mention it, but we'll get as far as we can. We'll continue tomorrow. Hopefully Mr. Yacht will be back with us. He was sick last week, and maybe get him up here and work a few problems with you guys as well. But let's just go ahead and get to it. Now, if we're not dealing with a right triangle, if we're dealing with what we call an oblique triangle, well, we have to use either the law of sines or the law of cosines if we want to solve a triangle. Now, these instructions here, when you're asked to solve a triangle, they're really asking you just to find any missing angle measures or any missing side lengths. Okay, it's just a very efficient way of saying that. So when I say oblique triangle, well, we're talking about a triangle that does not have a right angle. So all three of your angles will either be acute, or you'll have two acute and one obtuse. Okay, but regardless, again, all three of the interior angles should give you a sum of 180. Okay, so what does the law of sines say? If triangle ABC has side lengths of ABC, representing the lengths of the sides opposite the angles with measures A, B, and C, well then here we go. Here's our law. Okay, we're going to go ahead and create a proportion. And we'll talk about how to solve that in just a second. If you think back to geometry, the good old days, we named a vertex using a capital letter, but we used a lowercase letter to represent a side length. And we're going to continue to do the same idea here. Now, in order to use the law of sines, you have to have what's known as a pair. So you have to have not only an angle measure, but you have to have the side length directly opposite that. That's what we're going to refer to as a pair. Now, if you don't have a pair, then you're going to have to go ahead and begin the problem with law of cosines. All right, and again, we'll talk about that later. But let's just get right into a problem and see what you guys think. Solve triangle LMN. We got this triangle right over here. Round side lengths to the nearest tenth and angle measures to the nearest degree. So I went ahead and did the notes like we'd done previously. I gave you the boxes with the definitions and the main ideas. The examples themselves, you'll want to go ahead and jot down those figures. Okay. So it looks like I have angles L and M, 29 degrees and 112 degrees. I have side L, 22 units, and I'm missing angle N, sides N and M. Okay, so you'll notice we do have a pair for this oblique triangle. I have angle 29 degrees, and I have the side length directly across from it. Because I have that, we can go ahead and use the law of sines. So I'm going to say sine of 29 degrees over the side directly opposite that, 22 equals. Well, what I go ahead and write next depends on which side value I want to go ahead and solve for. Now, do you notice anything that I could take care of really easily? Yeah, angle N. Remember, we know that the sum of angles L, M, and N's got to be 180, so somebody help me out. What is 112 and 29 subtracted from 180? It is 39 degrees. There we go. 39 degrees. Now, even without that, I could have solved for side M, or now that I have angle N, I can go ahead and solve for sine N. Connor, what do you like? Which one do you want me to solve for first? M. Let's solve for M first. Okay, so if I want side M, I'm going to have to use the angle directly opposite that. So I'm going to say sine of 112 degrees over the side length I'm looking for. Okay. So I created my proportion. That's easy enough. How do I solve a proportion, though? Yeah, we cross multiply. So for this first one, I'm going to go ahead and show the middle step. We're going to have that M times the sine of 29 degrees is equal to 22 times the sine of 112. Okay. Now, if I want M, I'm going to go ahead and divide through by the sine of 29 degrees. There you go. Anything divided by itself is going to cancel. Okay. So now I've got an expression that's going to give me the length of M. All right. So let's see what that turns out to be. 22 sine of 112. Well, come on over here. 22 sine of 112. Whoops. Over, I believe it was the sine of 29. Okay. Was that right? Okay, there we go. All right, so I've got the expression in the calculator, so what should I get when I push enter? Okay. So let's say 42.1, because I believe the instructions said to round to the nearest tenth. Okay. So we'll say side M is about 42.1 units, whatever measurement we have here. Okay. Now, a couple things I want to go ahead and bring up when dealing with this. All I have left is to find side N. Could I just go ahead and use Pythagorean theorem? Oh, got a couple people saying yes. Why not? There we go. The Pythagorean theorem is only going to apply to a right triangle, so even though I have two sides, I cannot use that here. So we are going to have to go back to the law of sines. But one other thing I would encourage you, I would continue to work with the original pair. Now, you could absolutely go ahead and use the pair of 112 degrees and 42.1, but what did we do to get that 42.1? There you go. We rounded that. And we've talked several times before, rounding in the middle of the problem will definitely affect your answer. So if you were to use the exact value provided in the calculator, I mean, that would be okay. But I would just say start with what you already have. Sine of 29 degrees over the side opposite 22 equals. Well, what angle measure do I need in order to find side N? Okay, what's that, Connor? 39. So I'm going to say sine of 39 degrees over sine N. And again, now it's just a matter of cross multiplying and dividing. Now, I'm not going to show the middle step here. What I typically like to do once I get my proportion, I just go ahead and write out the expression for the variable I'm looking for. So it should be, in this case, 22 times the sine of 39 degrees over the sine of 29 degrees. Now, that's what I'm going to go ahead and continue to do. If anybody would like me to write out that middle step, just let me know. I can definitely do that. It's only going to take a few seconds. But let's see what this turns out to be. 22 sine of 39, okay, over, okay, trig, sine, and it always does it the second time I bring up the trig function. That's weird. Okay, 29. All right, so what am I going to get for this length? Okay, so I'm thinking about 28.6. That is perfect. So come on back here, erase that. About 28.6 units, and there you go. That is the law of sines. Now we will go ahead and derive the law of sines. In fact, the last problem on your assignment for this lesson is to go ahead and derive that. So you'll go ahead and try it on your own before we go ahead and talk about it together. But I would like to, at some point next week, also go ahead and show you the derivation for how we get the law of cosines. That one's a little more involved. Okay, so any questions on how I set up the proportion, how I solved for a missing side length, anything? All right, well, let's go ahead and try another one. Let's see here. So I have solve triangle XYZ. All right, so it looks like I have angle X is 64 degrees, angle Z is 41 degrees. So the first thing, I'll just go ahead and find that missing angle. 180 minus 64 minus 41. 70 what? Oh, I thought I heard somebody say it. 75, there we go. So 75 degrees. Okay, now I can use the law of sines because I start the problem having a pair. I've got not only an angle measure, but I have the side length directly opposite that. So I'm going to start off by saying sine of 64 degrees over 11 equals, okay. And what should we solve for first? Y or Z? Y. Okay, let's go for Y. So if I want Y, then I'm going to have to use 75 degrees. Sine of 75 degrees over Y. Okay, cross multiply. So let's see here. Eli, can you give me the expression that's going to give me the length Y? There we go. 11 times the sine of 75 degrees over the sine 64 degrees. Perfect. So let's see what that is. Control divide 11 sine of 75 over sine, okay, of 64, I believe. Is that right? Okay, so what should I be getting here? Okay, there we go. So 11.8. Perfect. There we go. Okay. Now again, I have two pairs that I could work from, but I always encourage you to just work from the original pair. That way you don't have to worry about your answer being off. So I'm going to say sine of 64 degrees over the 11 equals, now I'm looking for z, so I'm going to use the angle opposite that, sine of 41 degrees over z. Okay. And how about Sandra? What would z equal? What would I have to type in the calculator in order to get the length of z? What's the expression? Okay. There we go. Okay, 11 sine of 41, and let's see what we get here. Okay, so control divide 11 sine 41 over sine, bet it does it again. It did. Okay, that's weird. And then over 64, correct? Okay. So what should I end up with here? Okay, I think it's like 8.0 is what you end up with. Is that right? Yeah, that 2 is not big enough. All right, so I'm going to go ahead and say 8.0. Okay, and there we go. That is the law of sines. Not a whole lot to it, but it is very useful if you're not dealing with a right triangle. Okay, any questions on anything we've done? Okay. Well, that's as far as first and second period was able to get today. I do want to go ahead and do this. The next problem, this is just got snapshotted again. This is the problem that we already worked. This word problem right here. Why don't we go ahead and take a minute, have that copied down in our notes so that tomorrow when we come in, we can just get right to it after the happy minutes. Okay, so the next example, it says a person in a hot air balloon observes that the angle of depression to a building on the ground is 65.8 degrees. After ascending 500 feet, the person now observes that the angle of depression is 70.2 degrees. How far is the balloonist from the building? Okay. How far is the balloonist from the building? Okay, so pretty short lesson today, but once you have that copied, you want to go ahead and get your calculators back up to the front. We'll go ahead and start wrapping things up.